The next one is SqueezeNet. Basically, SqueezeNet is not the recent research. I think it was proposed in 14, maybe. I don't remember. So the SqueezeNet is very small and smart neural network, CNN, which has 50 fewer parameters compared to AlexNet, but the performance is comparable performance, and also has 500 times fewer number of parameters after compression. The speed is 3 times faster than AlexNet. By the way, the number of parameters and speed is not like linearly dependent, because this is completely different things. It doesn't mean if you have few parameters, you would have like if you have 2 times fewer parameters, it doesn't mean you would have 2 times faster computation. And SqueezeNet is the one example of fully convolutional networks. It doesn't have any fully connected or dense layers. And so here's the comparison table with AlexNet. So the baseline AlexNet had the performance of this one, 57, and baseline of SqueezeNet has almost the same, and even a little bit better. Same accuracy on ImageNet, top 1 accuracy, and the paper also mentioning about neural network compression, and basically there are a lot of compression methods. The simplest one is to decrease your bit to store your weights. For example, in your personal computer, you use, for example, 32 bits for storing each data. You can decrease the number of bits for each weight to, for example, 8 bit, and in this way you can compress 4 times, right? It's very straightforward compression way, compressing the network. And also there's another paper which is deep compression. They use multiple tricks to compress the network, not only decreasing the number of bits. And after doing compression, the final network is they're almost similar, but the size of network is 0.5 megabytes. It's really a small network with comparable accuracy with AlexNet, but it wouldn't be comparable with VGG or GoogleNet. They only have comparison with AlexNet. So
sorry, I have a quick question. Like the compression here is size in memory or the size of the disk? Like the megabyte is referred to. What is model size?
Which model size?
When you say model size 240 megabytes, does it mean like just all the weights together?
Weights.
Megabyte, or just the size of memory or the size of the disk?
And this is the size of weights.
Okay.
Yeah. All weights are in this size. Yes, SqueezeNet used a lot of tricks. Let's discuss one by one. The first one is, we already mentioned about replacing 3x3 with 1x1 filters. So they have done the same thing, replacing 3x3 filters with pointwise filters, convolutions. And by doing this, they reduced the computation by 9 times. And that means like 3x3 filter, you would have 9 multiplication, and in 1x1, you would only have 1 multiplication. And next trick is use the 1x1 filter as a bottleneck layer. We already shown it in previous slides. So this is to decrease the number of channels of input tensor, and then do the next operations. And and they have fire module in SqueezeNet. Fire module has 2 different components. they use the 3x3 filters in Fire module. And basically, you cannot construct a CNN with only 1x1 convolutions because you have to deal with special dimension, right? So if you use only 1x1 convolution, you wouldn't have good performance at the end. So you have to use at least 3x3 filters in some layers. And in Fire module, they use 3x3 filters, and this affects the final accuracy. And late downsampling is, so in VGG, you basically doing convolution operation and max pooling, convolution operation and pooling. But what they proposed is doing downsampling later after some number of layers, because they said if you downsample the feature map at the earlier layers, you would lose some special information in feature maps. And another thing is network compression. So basically, network compression are applied to big networks like AlexNet or VGG. But they proposed the smaller networks can also be compressed. Like here, the AlexNet can be compressed here, and SqueezeNet can also be compressed from 5 megabytes to 0.5 megabytes. And the another trick is 1x1 and 3x3 convolution rate analysis. This is two types of convolutions are used in Fire module, and they also have analysis about how many 1x1 and how many 3x3 filters to use in Fire module. And they also proposed bypass connection. It's very common in ResNet and DenseNet. And this bypass connections helps to gain the lost information because of bottleneck. So the Fire module basically consisting of two different components. The first one is squeeze layer. The second is expand layer. They first squeezing the input tensor by using 1x1 filters, which we can also call this a bottleneck layer. And the second one is expand layer. After the bottleneck layer, you would gain some special information again, and they use 1x1 and 3x3 filters. So this is the Fire module used in SqueezeNet. So for your input tensor is here. This is your bottleneck layer. You can decide on how many filters to use here. And in expand module, expand component, you use multiple 1x1 and multiple 3x3 convolution filters. So here's the three different versions of SqueezeNet. This is the first version, which doesn't have any skip connections. So they use convolution and 9 Fire modules, 9 of them here, and one again convolution, and then softmax. So they don't have fully connected layer. This can be thought as fully convolutional layer network. And the second one is the using simple skip connections. So skip connections is to gain the lost information because of bottleneck layer, and they use simple skip connections. And then why this is simple? Because the number of channels is the same, and it's very easy to concatenate, very easy to add this feature map and this feature map. And this is the complex skip connections. Why is complex? Because you want to add this feature map, which has a different number of channels, to 128 number of channels feature map, and that's why this is called complex connections. But at the end of experiments, they decide they get the best performance using only simple skip connections. So yeah, SqueezeNet has not so big contribution, but they have great contribution in terms of analysis. They analyze different things at the same paper.